All right, now that we remember what slope is, now we can apply it to graphing equations of lines. Okay, so this is where we get back to our familiar slope-intercept form. So to remember, slope-intercept form of a line. We just talked about standard or a little earlier. Now we're talking about slope-intercept is given by this equation y equals mx plus b, everybody's favorite form of the equation of the line, y equals mx plus b, where of course slope is m and the y-intercept is given by b. So again, we talked about y-intercept. Y-intercept is the point where the line goes through the y-axis, where it is on the y-axis, where the y-axis and the line intersect. And slope is the average rate of change of the line. For a line, average rate of change is the actual rate for every single unit because it's just consistently changing by the same amount. But so if I keep using average rate of change, it's more about how we're going to talk about it in the future when we get to nonlinear functions. All right, but anyhow, if we know slope-intercept, we can, and y-intercept, we can graph an equation relatively simply and quickly, as in these two examples here. If I were to look at this one right here, we have y equals 3/4 x minus 2. So we can identify slope right away. Slope is the coefficient on x. This is important. Slope is 3/4. Slope is not 3/4 x. Slope is 3/4. Just the coefficient is the slope. Okay, and the y-intercept is given by -2. So, knowing that -2 is the y-intercept, I could go ahead and go on. Let's label our axes just to be clear. 1, 2. Okay, it's worth giving a scale to your axes. But we know the y-intercept is -2. So here's -2. I know the line goes through the y-axis at -2. And that the slope is 3/4. So that is a rise of 3 and a run of 4. So it is up 3 over 4. And that's my other point. So right, plus 3, rise over run, plus 3/4. And then I can connect those 2 points and I'll have a nice equation of a line. If you want to be real accurate, you could go ahead and find any other points using that 3/4 slope. You get a nice graph of the line here. Very familiar. Did that a bunch in geometry, algebra 1, I'm sure. So hopefully this one is nice, quick, easy review. If we come on to B here, it says 2x plus y is 5. So similar, but one other thing has to happen first. This one's not given in quite the same form that we're used to. We have all the right terms, but if I want it to be in slope-intercept form, I'm actually going to start by subtracting that 2x away. So I would have -2x plus 5. Now I can identify slope and y-intercept. So be careful that you have y isolated by itself before trying to identify slope. So slope is -2, y-intercept is 5. We can go to our graph, 1, 2, so forth. So here's the y-intercept of 5, and the slope is -2, which means I would go down 2 over 1, down 2, zoom in a little bit, over 1 to get to my next point. And then I can connect the dots. And I could keep going down 2 over 1, down 2 over 1 to make sure I get a nice straight line that follows the given slope. The more points you can plot, the more accurate you'll be. If you can use a straight edge, you'll get a really nice straight line. All right, so there's a basic review of slope-intercept form. I'm sure you feel pretty comfortable with that, but you'll get some practice with that in the homework. Okay. Just to review also with respect to slope, there are really only a few different particular types of slopes that you can get, but we want to review those real quick. We saw an example of the first two in our previous examples here. If we are trending upward as we move from left to right, if we're going upward, this is called a positive slope. Right? When m is positive, you will move upward as you go from left to right. And we're always talking about as you move from left to right. So if I say the graph is going up, that means as x goes from left to right, the y value is getting larger. If we have a negative coefficient, that's a negative slope, that means we're moving downward as the function moves from left to right. Okay, negative slope means moving downward from left to right. A zero slope means that we're not moving up or down as we go from left to right. So we would have a graph like we see here. Nice flat horizontal. Think about if you were walking and you were walking on terrain that had no slope. That means you're walking on nice flat ground, right? Here I am walking. Hello. Zero slope means flat ground. And you'll notice what happens in the equation is that if you have zero slope, then m is equal to 0. So when you multiply 0 times x, that term drops out, and you're left with just the y-intercept. Y equals 3, there's our y-intercept. So just be making sense of all of that. Zero slope means the x term drops out. Then the last is if you have an undefined slope. This one's a little bit weirder algebraically, but what we mean is that if y2 minus y1 and then x2 minus x1, if you have the same 2x coordinates, then these two would cancel each other. So if x2 equals x1, then you'd get some number in the top, delta y, but you would have 0 in the denominator. So if you have two different points, x1, y1, and x2, y2, they're different points, but they have the same x coordinate. So for example, this point and this point. Well, that's going to cause the slope formula to yield an undefined expression. But we visually can understand what's happening here very easily. If you have 2 points with the exact same x coordinate, then that forces you to draw a vertical line. And so when we say an undefined slope, we really just mean a vertical line. And the vertical line is given by x equals some number because every single point has to have the same x value. Okay, so if you've ever wondered why we call it an undefined slope, now you know. Alright, so there's some basics on the different types of slope. We'll do one more video for this section on what a linear function is and some other important attributes on it in our next video.